Tiwari, member of Department of Commerce. I would like to welcome you all to the third technical session on sample size determination by Dr. Priyanka Dikshit. It is an honor for me to introduce our guest, our resource person to all of you. Dr. Priyanka Dikshit is an assistant professor and chairperson of Center for Health and Social Sciences, School of Health System Studies at Tata Institute of Social Sciences, Mumbai. She teaches in the Masters of Public Health, Master of Social Work, Direct and Indirect MPhil and PhD programs. She is the principal investigator of National AIDS Control Organization funded projects, and in the past, she has coordinated various national level projects related to tobacco consumption, nutrition status of children, and female sex workers. Most of her work is related to NCDs, evaluation studies, and public health issues based on large-scale surveys. She has published more than 30 research papers in international and national journals. I extend a warm welcome to you, ma'am, on behalf of our college, and thank you very much for accepting our invitation and fetching time for us. So I would request ma'am to begin with the session. Over to you.
Yeah. Thank you, ma'am. And once again, good afternoon to all of you. So in this session, we would going to learn some of the issues related to sample size determination. Before I should start this session, I'm hoping that how the sample technique has been, different type of sampling strategy has already been covered. And also you all are already aware some of the basic statistics, because we are going to use all those things. And within a short period of time, it is not possible to revise entire thing, but in between, if some concepts are needed, I will try to explain briefly. Okay. And before I should start this determination of sample size, I would like to also inform that it's a big topic. There are various things which comes under the sample size. Okay. And also according to the requirement, according to your what you wanted to estimate, what is the purpose of your study. Okay. According to that, sample size formula may differ. Okay. So sometimes I hope you might be aware, then if we talk about inferential statistics, basically we are trying to focus on two parts. One part is about the estimation. Yeah. One part is about the estimation, and another type of research question where we are trying to compare the two groups or more than two groups. So we can divide our entire research question into two domains. Either it could be the estimation or it can be the comparison. So if I start with some research question, let's say my research question is to find out the malnourished children in Maharashtra. Yeah, I have to find out, let's say I got the funding and Maharashtra government is interested to know that what is the situation of Maharashtra in terms of the malnourished children. So in this situation, I hope you can clearly identify that our research question is about the estimation. We have to estimate the total number of children, those who fall under the malnourished, those who are in the malnourished situation. My most of the examples are related to health. I hope it is okay for all of you. You can try to relate in your research problem, whether it could be something related to finance, economic, or maybe commerce. Yeah. So one is about the estimation and another could be comparison. So when we are saying comparing the two groups, so it can be, let's say I'm trying to compare whether the situation of malnourished children in Vidarbha region is significantly different from the Mumbai region or not. So here you can say that it is the problem which comes under the comparison. We have a two district. We are first trying to calculate the malnourished children and then we are trying to compare. Okay. Now, similarly, there might be in various situations, nowadays our students, when they complete their master's degree, they are involved with maybe the ministry, or some students may be working with WHO, or maybe a different NGOs, and their main problem is to, they have already implemented, organizations, government body, they have already implemented various schemes. Now their main target is to check whether that scheme is effective or not effective. So how we can check and how we can categorize that problem in these two situations? So we can say that it is again a comparative type of study, because if we wanted to find out the effectiveness of any particular program, okay, any particular program, you can name any of the government program, let's say it's Ujjwala Yojana, yeah, Ujjwala Yojana, or maybe it's a, let's say a Dhan Lakshmi scheme, okay, anything. So then what we have the baseline information, we have a baseline indicator, and then over the period of time after implementation of that scheme, again we will capture the same data, same variable, same indicator, and then we will compare what was the situation before implementation of the program and how it got changed after the implementation of program. Again, this is the problem of the comparison of two groups. Yeah. So we can conceptually say that this is the entire thing comes under the two broad area. Okay. Now, entire thing is not possible to cover. So in this session, I will focus on the most important thing, which is about the estimation of a particular parameter. Okay. And then we can have some interaction in between. If you wanted to ask, I would be very happy that this session would be interactive rather than just I will give information and I don't know whether you all are getting or not. Okay, so I hope that you will ask question in between. Yeah, so just a minute. Okay, now if we look at in the sample size determination, so as we all know that we have a population, and collecting information from entire population is next to impossible, and that's why ultimately we have to rely upon the sample. And how we are going to different strategy of sampling has already been covered by some other professor. I got that information. So whenever we are talking about the sampling, yeah, so always there is a chance that we can commit certain error whenever we are trying to estimate something with the help of sample. So what is my main purpose? Our main purpose is to estimate something based upon small sample. And then we are trying to project our estimated thing. And we are saying this is the parameter, this is the statistics, which is actually going to predict the population phenomena. Yeah. So we are trying to rely upon sample. And then based upon sample, we wanted to give the information of the entire population. Now, population can vary according to your research question. It can be a district, it can be state, it can be maybe a national level, it can be world level. It is totally depends upon your research problem. So whenever we are talking about and we are working on sampling and we are trying to generate any estimate based upon sample, there is a possibility that we can commit two types of error. Okay, when it comes to the sampling. So one part is the total error. We can say that error can be divided into two parts: sampling error and non-sampling error. Okay. Now what is sampling error? So sampling error is the error that arises in the data collection process. Now, for example, let's say I wanted to estimate the malnourished children in the Maharashtra. Yeah. So what I need first, I have to prepare the sampling frame. I hope you all are aware about the sampling frame. So sampling frame is nothing but we need the entire list of the children, entire list. Okay, entire list of the children of Maharashtra state. From where we will get that list? That list most of the time, whenever it is a community survey, most of the time that sampling frame we will get from the census, latest census. So at present, we have to rely upon 2011 census because at present we don't have the recent census. So from 2011 census, we will get the information that how many children, let's say my target is to calculate the malnutrition among 0 to 5 years children. So 0 to 5-year children, total number of children from 2011 list I will get. Okay, that information I will get from the census. Okay, now there is a possibility sometimes maybe if you are do not want to take a old sample census information, you can maybe ask from the community that how many children are there. Okay, how many children are there, those who are in the age group 0 to 5 years. Fine. So in that situation, sometimes there is a possibility that your list, that sampling frame is not complete. Some of the section has been missed out, and maybe the Gram Panchayat or maybe the local authority who used to maintain the record of the total number of children, their record list is incomplete. So what happened, yours in that situation, when your sampling frame is not consistent and it is incomplete, so whatever sample you will draw, that sample will not truly represent the population. So in that situation, there is a chance that you can commit sample error, sampling error. Fine. Now coming to the another part, which is a non-sampling error. What is non-sampling error? So non-sampling error is the error that arises in the data collection process as a result of factors other than taking a sample. What does it mean? So non-sampling error is the whatever error we can commit which is not related to sampling. So let's say my sample frame is perfect. I have able to include all the total number of population, total number of children, those who are 0 to 5 years. Okay, my sampling frame is fine. I have applied the appropriate procedure, simple random sampling, let's say, to recruit the number of desired number of the children from the selected community. But there might be a error, there might be non-sampling error in terms of my tool, the questionnaire is not appropriate. Okay, that could be one type of non-sampling error. Another type of non-sampling error is maybe I have given the training to the investigator, but in training was not efficient. It was not actually able to provide the sufficient and necessary information to the investigator. So there is a problem in the training. Fine. So that part comes under the non-sampling error. And also when the investigator have collected information from different community of Maharashtra, because the sometimes maybe I have recruited too many investigators that I'm not able to supervise. So without supervision, there is a possibility that we will get some irrelevant information. So all those information, all those error which is not related to the sampling comes under the non-sampling error. It comes under the non-sampling error. So whenever we are trying to generate any estimate with the help of sample so that it should give appropriate information to the population, we always want that our sampling error and non-sampling error should be minimum so that my estimate, sample estimate would be reliable. Yeah, would be reliable. Fine. So we have to minimize the sampling and non-sampling error. Fine. Now, what are the other factors which comes under the sample size? So the size is mostly related to that how much time you have and how much cost is involved in the data collection. Okay, most of the time, like I'm getting that query from the different researcher or independent consultant that they are asking that, ma'am, you calculate the sample size and we will incorporate that thing in our report. But without knowing that how much fund you have, how much time you wanted to spend in the field, and also what is your main motive, what is the main objective, no one able to calculate the sample size. So scientific calculation is the one major part, but at the same time you have to also take care of the time and the cost. According to the scientific calculation, let's say I have calculated and my sample size shows that 1 lakh sample from Maharashtra, but that organization is small. And maybe as an independent researcher, if some of you are students, maybe it is next to impossible to collect 1 lakh sample. Okay, if you are doing PhD or maybe some other certificate program where you have to complete a one paper or maybe a dissertation, hardly within 3-4 months, if you completely devote in the field, you can achieve 400 sample. Yeah, so when you are calculating the sample size, you have to take care of the, first you have to identify and maybe keep in mind that how much time you are willing to spend in the data collection, then how much money you have. Yeah, how much money you have, that how much, if you are trying to recruit some investigator, because if your sample size is large, obviously you have to recruit a more number of investigator, and then your money will increase. So you have to optimize, you have to decide that within a fixed time period, within a given amount of money, I should give the scientific idea of my estimate. So we have to consider all these factors when it comes for the determination of sample size. Yeah, and at the same time, so there are some pros and cons. If you increase your sample size, it's good that in that purpose you can additionally calculate some more information. Let's say if you're trying to calculate the malnourished children in the Maharashtra, you have decided 400 sample size. Yeah, but you have a sufficient time, you have a money, then you have thought that, okay, in place of 400, I should increase my sample and I can able to achieve, let's say 600 sample. Okay, so you have collected 600 sample, and within 600, you also have taken the information of the religion of the household. Okay, some of the information you have taken from the Muslim household, some of the information you have collected from the Hindu household. So in that exercise, there is a possibility that you can also try to calculate or compare the situation of Muslim versus Hindu children malnutrition condition. Yeah, so if you are going to increase sample size, you have a other opportunity to address some additional research question. Yeah, but at the same time, you have to also see that you should not just increase the sample size, you should increase the sample size so that you are able to manage the investigator. You have the uh, entire, you are able to supervise the investigator. It's not like you have just given the job and they have collected information. And then ultimately, when you have started the data collection at that time, you realize that the sample size, there are a lot of problem in the data which has been collected. So you have to mindfully take all these things when you are going to calculate the sample size. Okay, so this is just a background. Now I will give you some information related to some of the small issues or the concept which ultimately we are going to use in the sample size calculation. And I hope you ask some question in between. Yeah, otherwise I will start asking. Okay, when it's so automatically, if you trying to calculate sample size, you just Google it, sample size calculation formula, you will get lot of calculator. Yeah, but you have to think that which formula is applicable. Okay, what is the basis of generating that formula? It's not like any formula you can use. Okay, so there are basically, in statistics, if we look at statistically, there are two types of error involved. Okay, And on the basis of these two types of error, with the help of these two types of error, we are going to discuss about the sample size formula, how it has been derived, how the formula has been derived. So there are two types of error. One error is the absolute error. Okay. So absolute error is the magnitude of the difference between the exact value and the approximation. Okay. So what does it mean, absolute error? So let's say when I'm saying that I have to estimate the malnourished children in the Maharashtra. That is my research question, which comes under the estimation part. Okay. So what is your main thing? Can someone say what I'm wanting to calculate? What I wanted to calculate? What is my main outcome of interest? Yes, someone? I don't know whether you are interacting with your faculty or not. Okay. So absolute error is what? Absolute error is, so my target is to calculate the malnourished children in Maharashtra. For calculation of total number of malnourished children in Maharashtra, it's very surprising that I have to assume that how much is the malnutrition condition in the Maharashtra state. Okay, my target is to calculate the total number of children, those who are malnourished. But before I should calculate with the help of formula, I have to hypothesize that value. And from where I will get that value? From maybe a previous survey, yeah, or maybe the latest survey. There are a lot of survey has been recently conducted, and they have shown that the malnutrition condition of Maharashtra state is, let's say, 40%. Okay, malnutrition condition of Maharashtra state is in 2015 year is 40%. That information I got. Now with the help of this information, I will calculate my sample size for 2022, so that with the help of that sample, I should calculate my total number of children, malnourished children in Maharashtra. So I hope you are getting, we have to calculate the total number of children, those who are malnourished in Maharashtra. To calculate this thing, I have to first find out that what previous study have shown. Okay, I have to take that evidence, and on the basis of that evidence only I can proceed. Yes, is it okay? Is it okay? So when I'm estimating, so let's say from the previous study, I came to know that in 2015, there are 40% children, those who are comes under the malnourished. Fine. So what is, so that 40 is my that hypothesized value. Fine. At the same time, I have to also conceptualize that how much error I will commit. So when I'm calculating the sample size, because as we have already discussed that whenever we are going to use the sample to estimate anything, there is a possibility of committing error. So that also, that how much error we are going to commit, that also we have to assume. So I have conceptualized that 40 was the total number of children out of 100, those who are malnourished. And there is a possibility that when I will calculate my sample size, I can commit some error. 4% error I am going to commit. 4% error I am going to, 4% error if I am going to commit, what does it mean? This indicates that if actual malnutrition condition is 40, my sample may give some error, 4% error. 4% error means 40 minus 4. So there is a possibility that my estimation may vary from 36 to 44. Are you getting? So plus minus 4, because I have mentioned that 4% error I am going to commit. So there is a possibility in my estimation may vary from 36 to 44, because 40 is the actual value. From 40 to 40 minus 4 and 40 plus 4. In this range, my answer may lie. This thing also you have to conceptualize. Okay, when you are trying to estimate the sample size. Okay, when you are trying to estimate the sample size. Is it okay? Is it okay? Up to this one, it is clear to everyone?
Ma'am, there are few questions now itself. You want to pick it up now or later?
Yes, I think you can ask in between if you have something. Yeah.
Komal ma'am,
Yes, ma'am. Just
you
a
can ask at least few
Okay.
questions.
So, ma'am, there is a question. If there is no previous data, how do we proceed then?
We have to have some information, isn't it? Maybe we don't have the data, then maybe we have some media information. Time to time basis, we are getting information from newspaper, or maybe let's say for Maharashtra, you don't have a data, but at India level, you have information. Then you have to hypothesize that whatever situation is in India, the same situation would be in Maharashtra. So the same thing you can apply in the Maharashtra. So with some base you have to start. With some base you have to start. Without this one, it is not possible.
Ma'am, there is another question. How to find a sample error?
Sample error, how to find out the sample error? So sample error is actually, it's the separate exercise, which is not the part of the this one sample size calculation. It is a separate thing. So maybe when you are trying to estimate something, let's say you have estimated the malnutrition condition, and you found after calculation, you got information, you have calculated, and your calculation shows that the malnutrition condition of Maharashtra state is 60%. Okay, 60%. But if you look at the previous study, which happened maybe 3-4 years back, they are showing just 30%. Then you have to match with some gold standard indicator, and then you have to find out that why you are getting so much difference over the period of time. We are expecting that situations are improving, isn't it? Because government has put lot of effort, people are now day to day, they are getting education. So our expectation is that most of the health indicator, apart from the non-communicable disease NCD, the situation is getting improved. So why we are getting 60%? Then you have to find out the reason. There is a possibility that maybe some of the error is from the sampling, some part could be the non-sampling error. Maybe your list was incomplete, that's why your list was incomplete. Or maybe what happened, you have only included those people, who are from the marginalized community, and that's why your prevalence is very high. So there should be some comparison, and then you have to find out. Yeah, is it okay?
Okay, ma'am.
Yeah.
Another question is they want to know if it is compulsory to show sample error in a study.
Sample error, see, we can't, it would be very difficult to segregate the total error into sampling and non-sampling error for a student. It need a complicated exercise. Okay, so non-sampling error we have to we can control. It's not possible that we have entered the information and then we are saying that okay, now what to do with the non-sampling error. So non-sampling error we have to actually, we can reduce when we have a proper control on the investigator, when we are actually monitoring our that field properly. At that time we can actually able to control the non-sampling error. And sampling error also, when you are preparing the list, you have to ensure, you have to discuss with various technical advisor, you have to verify the list, and then you can go ahead. So these are the some of the steps through which you can reduce sampling and non-sampling error. Is it okay? Yeah. So, yeah.
Proceed, ma'am.
Yeah. So now if we look at, so there was the one absolute error, and we have to also conceptualize that how much error we will commit. Okay. The next concept is related to that again, that which is related to the alpha, which is type 1 error. Okay. So I hope you all are aware that if we are working on any continuous data, let's say if the height of the person, weight of the person, or maybe age of the patient, then these variables are in continuous scale. Okay. So if we on x-axis, if we have the age of the information, or let's say weight of the information, or let's say blood pressure of the patient on x-axis, on y-axis we have the proportion of population. In that situation, if we plot a graph, we will get this type of shape, bell-shaped curve, which is known as a normal. That variable are normally distributed. Yeah, variable are normally distributed. And in whenever we are going to perform any test, we have to assume that how much error we are able to commit. Okay. So if it is sometimes in social science field, we can say 5% error. Sometimes we can increase up to 10%. Yeah. So this 5 and 10%, what it does, what it shows the area under the curve. Yeah. It shows the area under the curve. And this 5% where it's going to touch this x-axis, that is known as our z value in statistics. That is known as a z value. I hope these basic things you all are aware. So corresponding to 5% alpha, 5% area, your z value is 1.96. It is already given in the statistics. The statistician, they have calculated, and then they found that corresponding to the 5% area, the z value is 1.96. Okay, so this is the z value. So if my answer is going to lie in this in between area, which is the white area, we are going to say we will accept the null hypothesis. Yeah, this is just a quick revision because I hope this has been already covered. Now, if our answer will lie in this black region towards the left and towards the right, we are going to reject the null hypothesis. Okay. Now this we are going to use in our calculation. Okay. So now finally, how we can derive the formula of sample size. So sample size formula derivation is nothing but, so let us consider the estimation of proportion of a characteristics in a population. So in simple random sampling, okay, in simple random sampling, if you use the binomial distribution formula, so standard error, do you have an idea about standard error? What is the standard error? Anyone knows standard error formula? So standard error is nothing but standard deviation divided by root over n. Yeah. So standard error is nothing but standard deviation divided by root over n. Fine. So what is n? N is nothing but the total number of sample, and standard deviation in case of if you look at in case of the binomial distribution or Bernoulli distribution, it is NPQ. Yeah, it is NPQ. And in Bernoulli distribution, it is PQ. So standard, so we are finally going to derive the formula of sample size. So this will come from this formula, which you can see in the slide. So standard error of proportion is equals to standard deviation divided by root over n. And what is the standard deviation? Standard deviation is nothing but under root PQ divided by n. Okay, so from this one we will get the formula of sample size. Yeah, so what is the sample size here? So from here, if you just take n in the left hand side and other thing in the right hand side, so finally you will get the formula. So what is the formula you will get? You will get, so from here, so this is our standard error. Okay, standard error formula is okay. Now, so this is clear, or if you have any doubt, you can ask. This is fine. Okay. Now, this formula is based upon the absolute error, which I have discussed in the previous slide. So absolute error is nothing but we are going to estimate the mean. Okay, X, we are going to estimate the mean. We are going to estimate the proportion. Let's say if you look at this formula, X is my proportion. But there is a possibility that in terms of some standard error, I have to show that how much is the acceptance of error. Okay, so X is my calculation plus minus Z into standard error. Okay, are you aware about this formula? Confidence interval of mean. Confidence interval of mean, do you have any idea? So confidence interval of mean is nothing but mean plus minus Z into standard error. Okay. So from this one, if you look at this right hand side, Z into standard error is nothing but the absolute error. This is the absolute error. Okay. And this absolute error, if we derive, finally we will get this formula, which is n is equals to 1.96 square into P into Q divided by D square. So I request all of you to please just note down one formula, last formula. N is equals to 1.96 square into P into Q divided by D square. And then I will explain each and every term. Please note down this formula in your notebook, because with the help of this formula, we will calculate some problem. This is the application. So you have to use pen and paper. Yeah. Without this, you will not able to get the idea. Is it okay? Have you all written? Yeah. So this is the final formula for sample size. What is P? P is the proportion, or P is the probability in which we are interested. So at present, if I'm interested to calculate the sample size for malnourished children, so P is the value which I have assumed, 40%. Yeah, P is that value. You can try to relate with your example. So P is the value in which you are interested, what you are trying to calculate in your objective. From that research question, you have to identify, you have to look at the previous data or any other secondary report, and you have to write down how much is the P, prevalence. What is Q? Q is nothing but 1 minus P. Yeah, what is Q? Q is nothing but 1 minus P.
You, ma'am?
Yes. Yes. Fine. So P is the prevalence. Q is 1 minus P. And D is how much error you are thinking that you will commit, whether it is a 4%, whether it is a 2%, whether it is a 6%. So that is D. Fine. And what is 1.96? What is 1.96? 1.96 is nothing but a value corresponding to the 5% alpha. So is it okay? If you have any doubt, please ask. Because now we are going to calculate sample size. Is it clear?
Yes. Do you have any doubt?
Okay. Yeah.
You carry on.
Yeah. So now we are going to use this formula and then we will calculate sample size. Fine. So let's say this is the example. Suppose a program administrator in an area require a survey based estimate of crude birth rate that indicate the number of births occurring per 1,000 population in a year. The information is required to decide how many vaccine. What we are going to calculate to information, the information is required to decide how many vaccine would be required in order to protect the newborn babies from a certain disease. Okay. I hope you all get the idea that what we are trying to calculate. We have to find out how much vaccine is required. Okay. What information has been given? So information we have, if the crude birth rate is 30, that is prevalence is 0.03. A value of D equals to 4 per 1,000 would mean that estimate of CBR can vary in between 26 to 34. Is it possible to check the vaccine requirement corresponding to these two values of the CBR? Yeah. So is it okay? Is it fine? So what we are trying to calculate, we have to find out how many vaccine a particular company or government should give in that area so that they can give that vaccine to all the newly born babies so that they can be away from a particular disease. Okay. So how we can calculate? So we have to ultimately calculate the total number of newborn babies because each and every newborn wants that vaccine. So total number of vaccine should be equals to the total number of newly born babies. Fine. So is it okay that what we are trying to estimate? We are trying to estimate the total number of children. Is it okay? Is it fine? Now for total number of children, so if we use this formula, so 1.96 is, let's say my alpha is 5%. Most of the time, social science field 1.96 is fixed. Yeah, because generally 5% error we are assuming. So don't worry, you can take 1.96. Okay. Now what is P? What is P? Can somebody tell the information? What is P? Yes, someone? How many? 129 people are here. So I'm expecting at least one person should answer. What is P? Yes?
People are answering.
Yeah, okay. Yeah, so P is 30. 30 means, so we are assuming that the out of 1,000 population, 30 births are happening. So that is my prevalence. है ना? That is my prevalence. Fine. So 30. So in when we are trying to put in the formula, we have to. So what 30 out of 1,000? है ना? 30 out of 1,000. So then we have to use P is equal to 0.03. 30 divided by 1000, which is 0.03. Fine. Is it okay? What is Q? Q is 1 minus P. So how much Q you will get? 0.97. Fine. Okay. And then how much was the D? D, it has this also, it is up to you. You have to assume that how much error you are going to commit. Okay. So again, it is sometimes maybe 2, sometimes 3, sometimes 4. It is up to you, because ultimately you realize that if you are going to change this D, your sample size will change. Fine. So let's say at present, I'm assuming that I'm going to estimate the total number of children born, but there is a possibility that 4% error I can commit. There is a possibility that actual value is 26, but I'm saying 30 births. There is a possibility actual birth is 34, but I'm saying 30. So this plus minus 4 error I'm going to commit. So again, this 0.04 is my this one. Fine. 0.004, 4 per 1000. So 4 divided by 1000, again we will get 0.004. So we got P, we got Q, we got D, margin of error. This D is known as a margin of error. With the help of this one, we can calculate the sample size. Yeah. So can you all try? So if you look at 1.96 into 0.03 into 0.97 divided by 0.00004 square. This is the we put in the formula, and then we finally got 6,987. Is it okay? So this around, if we can approximate it, we got 7,000 population. Fine. So 7,000 population is my total sample size. Is it okay? Is it fine? Yeah. But if you look at, so when you are going to conduct an interview, when you are planning to recruit and identify the total number of children in community, how you should get the respondent? Whoever will come, you are going to ask, or you are going to visit a household? So this is the household, isn't it? We are going in a household. So 7,000 is the population. Okay. And if we assume that on an average, the household size is 5 in Indian setting, so then how many households I have to visit to capture the 7,000 population? Is 7,000 divided by 5, which will come 1,400 household. So to get 30 children, to calculate the total number of children, those who are newly born, we have to visit how many? We have to visit 1,400 households. Yeah. Is it okay? This is fine, isn't it? Yeah. So if in this formula, so at present, if you are going to start this sample, first time you are learning, so you just stick with this formula. N is equal to 1.96 in square into P into Q divided by D square. Okay. So P is the prevalence which you wanted to estimate. Q is nothing but 1 minus P, and D is the margin of error. So if you see, if you are going to change D and N, how they are related? They are inversely related. If D is going to increase, N will change, isn't it? It depends upon the D. Fine. Is it okay? So everyone got the idea? Okay, now I'll give one question. So, okay. Okay. So let's say in the same example, if my prevalence is, let's say, if there are in a particular community, there are 50 children ever born, then how much sample size is required? Can you all calculate? Can you all calculate if your prevalence is 30, then how much would be the sample size? And let's say D is as it is 4, but my P is going to change. It is now 50. Earlier it was 30. Now it is 50. Can you all calculate and give your answer? I'll give you 5 minutes. See, without doing it would be very difficult. So I request all of you to please do it. I hope some of you are doing. Just 2-3 minutes I'll give you and then I will ask.
Ma'am,
Yes.
Some answer is there, yeah.
Yes. Okay. I don't know. Others are also getting the same answer. So this is the total number of households or this is the total population, Rashmi?
can someone unmute Rashmi? Let her answer.
Yeah. So what we have to do, I think the formula is same. We have to just in place of 0.003, we are going to use 0.05 and then accordingly this will change. Yeah. So we will get, how much we will get? Others are getting the same answer. So whatever answer we will get, that would be the population. Now, if it is a household survey, then only you are supposed to divide by 5. If you are going to recruit a direct individual from a community, I don't know, then in that situation, you can keep the number as it is. Yeah, this is fine. This is okay. I hope now you all got the basic idea about the sample size. Yeah. Now, sometimes, I don't know whether you have realized or you come across such a situation. Sometimes, let's say we have the information that in some situation that prevalence of any disease is 5. Let's say I wanted to calculate how much is the hypertension. Okay, how what proportion of population are hypertensive in Mumbai? Yeah, that is my for that purpose I have to calculate the sample size. My basic idea is to calculate the total number of individual, those who are hypertensive. Okay. So from previous report, I came to know, or from that some study has been conducted in, let's say, Madhya Pradesh, and they found that the situation is 7%. 7 people out of 100, 7 people are hypertensive. So from that one, I have some hypothesization. I'm thinking that the age group of the population, those who are in Mumbai, they are younger than the Madhya Pradesh. So that is my assumption, and that's why I'm thinking that here the prevalence could be around 5%, not the 7%. So with some justification, I thought that the prevalence of that hypertension is 5%. So what is my P? How much would be the P? Now it is 5%. It is not 5 out of 1,000. So P is 5 divided by 100. Yeah. Now, what would be the Q? Q would be 1 minus P. Yeah. Design effect of 2. Design effect we have not discussed in the previous calculation, that I am going to describe here. And the third part is the margin of error is also 2%. Yeah. So in the same formula, this is a different notation. But if you look at the idea is same. What is 1.96? 1.96 ko we can also write Z square. So it is just a notation. So don't worry about that. So Z is equals to 95%. It means 1.96. My Z value is 1.96 into P. P is how much? P is how much? It's 5%. And then 1 minus P we can put. Yeah. And in place of D, we can put it's a 2%. So again, we can put 0.02. So from this one, this is our previous formula. This is my previous formula. But here, if you carefully look at design effect of 2, here one more additional information has been given. Design effect of 2 means what? So I hope those who have covered the sampling strategy, they have discussed about the simple random sampling, stratified sampling, systematic sampling. Yeah. So different type of sampling has been discussed in the previous class or previous lecture. So, when we are, so what would be the ideal situation? We always want that we should recruit the respondent with the help of simple random sampling. Yeah. With the help of simple random sampling, we should recruit the individual. Yeah, we should recruit the individual. So simple random sampling is always found to be the superior technique. But practically it is not possible. Practically it is not possible. Why it is not possible? So what is the, how we are actually doing a simple random sampling? So let's say out of at present, if I would say, out of 133 students, those who are attending online class, out of 133 students, 10 students I have to randomly choose. Okay. So if I'm going to adopt a simple random sampling, so what I should do? I will prepare a chit, 133 chit. Each chit should be identical. And in each chit, I will write a name or roll number of each and every student. I will make a 133 chit and then I will mix, and then at random I will choose 10 chits. Whoever comes, I will recruit those people in my sample. This is one of the best method. Okay, this is one of the best method where each and every participant will get an equal chance of being selected in our sample. Yeah, fine. But practically, if we look at, this is not possible. Na? At present, with 133 student, I can adopt this strategy. But let's say if you have to recruit, let's say total number of individual, let's say out of maybe a 5 lakh Maharashtra people, I have to, out of 5 lakh, I have to recruit 100. From where I will get the chits? How, who is going to tell us their name and address? It would be very, very difficult practically. So that's why there was the we should say that there would be that innovation of that stratified sampling, and then systematic sampling, and then probability proportion to sampling. So most of the time you will realize that if you have to select a respondent from the community, simple random sampling is very difficult. Practically it is not possible. So we have to adopt a multi-stage sampling design. And in multi-stage sampling design, there are various things will come. Like sometimes we have to stratified village according to some criteria. So stratification has been done. Then with the help of systematic sampling, we can recruit a household. From the household, then at random, we can choose a one person. So you realize that we are actually adopting a complex design. Complex design means if we are deviating from the simple random sampling, that is the complex design. Yeah. So when we are doing a complex design, then what happened? We are actually committing some error. We are committing some error. So that error comes under this design effect. This design effect. So if we are not adopting the simple random sampling, we have to increase our sample size to adjust to justify, to adjust that error. Okay. And that's why you realize that if in the information in the question, if the design effect has been mentioned, you have to simply multiply that design effect with the total sample size. Yeah. So at present, if you look at the prevalence of disease is 5%. So P is equal to 0.05. Q is equal to 1 minus 0.05. D is equal to 0.02 margin of error. And Z is equal to 1.96. And then multiplied by 2, because we are not going to adopt the simple random sampling. We are deviating from the simple random sampling. So that's why we have to multiply and we have to increase our sample size. So if we apply this design effect, finally we will get 912 individual. Is it okay? Is it fine? So this is the way. So there are, at present, we have discussed about the two ways of calculating the sample size. One way where the design effect information has not been given, then simply we can apply the formula, which is n is equals to 1.96 square P into Q by D square. Now, you might have asked question that why only 1.96? So 1.96 is not fixed. It's not fixed. Yeah. So 1.96 is depending upon your alpha value, your type 1 error. If you have chosen alpha as a 5%, then corresponding to 5% area, the Z value is 1.96. If your alpha value is 10%, if alpha value is 10%, then corresponding to 10% area, Z value is 1.64. 1.64. So if you are going to change your alpha, your Z value will change. And this corresponding to different alpha, how much would be the Z value? It is already given in statistics books. So don't worry about that part, that from where this 1.96 actually appeared. It's given. So it's up to you that you have to decide whether you are going to choose 5% alpha or 10% alpha. Now, how we are going to, decide whether it should be a 5% or 10%? Any idea? So in public health field, 5% error is acceptable. Sometimes 10% error is also okay. But in medical field, when we are going to test effectiveness of a particular drug or medicine, then we can't assume that 5% error and 10% error. Then we have to reduce our error. Then we can say alpha 1% is acceptable. Then your Z value will change. So I hope it is clear that how this 1.96 value came. Okay. So whenever you are going to calculate the sample size in any of the situation, you have to choose alpha. You should find out the prevalence. You should calculate 1 minus p, that is q. You also should assume that how much would be the margin of error, d. And then you can simply calculate. Is it okay? This is, I hope it is clear. Now, let's say, so whatever sample size I have calculated, let's say in this particular situation, when we have calculated, we found 1400 household. Now this sample size, let's say if my study is at India level, I have to calculate how much would be the crude birth rate. Okay. So if my study is at India level, then 1400 household from entire India I have to select. But if you wanted to give idea about each and every state, then from each state I have to take 1400. Are you getting? So this total sample size is also depends that at which level you wanted to give estimate, whether you wanted to give estimate at India level, whether you wanted to give estimate at state level, or you wanted to give estimate at district level or village level. So whatever would be your level of estimation, 1400 should be fixed at that level. So if somebody will say that no, I don't want India level, I have to give the estimate at state wise, because government wants to give vaccination and money to the different states. So for each and every state, I have to give 1400 household. I have to select 1400 households. So 1400 households into 30 states. So 1400 into 30. So that total number of household we have to select. So it's ultimately your choice that at which first you calculate the sample size, then you should decide that at which level you wanted to give estimate. So accordingly you can multiply with that numbers. Okay. So that is about the at which level you wanted to give estimate. Another important thing is, which you might have heard, that non-response. What is non-response? Any idea? So whenever we are trying to generate, whenever we are collecting information, let's say I have decided that from Maharashtra, I will select 1400 households. Fine. So I have started collecting the data. But then I realized that out of 1400, only 1000 households have given information. 400 households they have denied. They have not given the response. So that is the non-response. So most of the time, whenever you are planning to conduct a survey, you have calculated sample size. You have to also assume that how much non-response may occur. Fine. If the question is very sensitive, then you have to assume high non-response error. Let's say if it is about the sexual interaction, domestic violence. So people are not ready to give answer. You may realize that you are trying to convince the respondent, but they are not ready to give the answer. So then what happened? You have decided 1400, but finally when you have approached, 400 people are not ready to give the answer. So that would always be better that before you should go to the field, you should increase your sample size. In place of 400, 1400, if you are from previous people, from previous survey, you got an idea that in that community, if you are planning to collect information, you have to have you will definitely get a non-response. 10% non-response, so definitely you have to experience. So you increase your sample size 10% in the beginning, so that your sample size should at least 1400, and additionally 10% extra information. If they will give information, it is well and good. If they will not give information, they will come under the non-response, but your original sample size is not going to affect, because your original sample size, if it will change, then what happen? Then you are not able to estimate. Your estimation will not give the correct idea about the population phenomena. Yeah, so you have to adjust. So what all we have discussed, if we quickly summarize. So sample size for sample size estimation, you have to have some p value. You can calculate key value. You have to assume margin of error, and then you have to also choose a alpha. Then you, if you are not going to recruit participant, simple random sampling, you have to assume design effect. And then also you have to conceptualize that how much would be the non-response. So with all these assumptions, you are finally going to calculate the sample size, and then you have to match with your cost. Let's say 1400 at present I have calculated, and then I realize, oh, 1400, so it's not under my budget. Then what I should do? Then you should do some changes in this value. You maybe increase 4%, margin of 4% to 8%. You choose alpha from 5% to 10%, so that your household should be less. So this is all about your, trial and error, and the various strategy you have to adopt to finally arrive with the sample size which you are able to achieve with a given time limit and with a given cost. It's not purely the scientific calculation. Okay, so it's a combination of various things which we have discussed. So I will stop here. Yeah, and now we have a sufficient time. Now I'm expecting you all should ask some question, or maybe you can, if you have any question or example related to your field, we can discuss, so that you will get a better idea and clarity. Yes.
Thank you, ma'am. There is one question here. What is the basis on which we assume this margin of error in a particular study?
So see, so as I have mentioned, it is not a very hard and fast rule that you should choose 4. Sometimes, so it's up to what I should say. If you have a sufficient time, and if the funder is ready to give you the money, then most of the time we will try to choose the less margin of error, so that we are able to achieve the big sample size, because large sample size has its own advantage. For estimation purpose, when we are trying to predict some phenomena at population level, it is always better that we should increase our sample size. Hai na? But so it is up to you. Sometimes 2%, sometimes 4%, sometimes 5%, sometimes 1.2. It is up to you. So this is the general phenomena. There is no hard and fast rule. So up to 5%, 8% also it is okay. Yes.
And there is another question. Do we need to conduct pilot study to estimate non-responses?
No, for pilot, this one non-response, it's generally not advisable. You will get information. Let's say we have lot of study on time to time basis. Government and different organizations have conducted. If you just look at their report, methodology part, where they have written the sample size estimation and all, most of the time standard reports used to give information that how much was the non-response. So in general social science field, what we realized that 10% to 15% non-response is happening. If it is a general question related to healthcare utilization or health services, yeah, 15% is non-response has been observed. But if there are some sensitive questions, as I have mentioned, like domestic violence, which is very sensitive, isn't it? Or maybe your some other information which something hidden. In that situation, obviously you assume that more than 50% or maybe 20% non-response will come.
Okay.
Yes.
And there is another question. Can we use the sample size formula for all study design?
So one thing is, see, there are two things. One is about the sampling strategy and one is about the sample size determination. Okay? So in this class, I have discussed about the sample size determination. So now let's say 1400 household you have decided. How you are going to recruit these 1400 sample? It's a different, I think, lecture which has been covered. So if you have the list of all the household, let's say you are planning to select 1400 household from a district of, let's say, Mumbai. So if we have information of total number of households and their list is given, at random I can choose. But as I have mentioned, that simple random sampling, practically it is not possible, na? Because let's say I have selected with simple random sampling 1400. One sample I got from, let's say, Govandi. Another sample was in Virar. Another sample was in Vasai. Do you realize that how much travel I have to, how much time, how much money is involved to just select 1-2 sample? Why I should bother about that? So practically simple random sampling is very difficult. That's why we have to adopt complex design. Like first time we are dividing the entire households into different stratum. Within stratum, maybe you can choose at random village or wards, and then within wards you can maybe go systematic random. So that is the separate exercise. I'm not sure how much time we can give it over here. I think it should be, so basically the previous lecture which was happened, you have to relate with this one, and then you can decide which strategy would be better suited as per your study or research question. Yes.
Okay, ma'am. There is one more question. Can we use sample table for determining sample size?
Sample table, which sample table? That's why I have mentioned that if you just Google sample size calculation formula, you will get various formula and various online calculator. But I seriously doubt on those that calculator. I don't know. You should have a sufficient understanding. There are some formula which is actually based on proportion of population, which at present I would say it's not very scientific. So your sample size calculation should be based on prevalence of your outcome, not the proportion of population. Fine. So don't go with the proportion, go with the prevalence. What is your main outcome? On the basis of that, you should calculate the sample size.
And if responses are more or less homogeneous, can we reduce sample size as we have mentioned approximate sample size in the proposal?
So that would be again come under the sampling strategy. We always want that we should get variety type of sample. Fine. So that's why if you look at the strategy which has been adopted by various large scale data survey, if you have heard National Family Health Survey, district level health survey, there are various surveys are going on. So what they used to do, within a village, if they are selecting a ward or a village, they are maximum taking 22 household, because we have observed that within village, if we are going beyond 22, we are getting the same type of response. So your strategy should be, you should choose a sample from various regions so that you are able to capture variety type of responses, not a homogeneous response. So you should divide your sample in different place. But obviously you have to take care of your cost and money. है ना? Yeah.
Ma'am, what is the difference between non-response and response bias?
Non-response and response bias. Non-response, if we have approached someone and that person was not ready to give response, that is a non-response. Yeah. Response bias means the person has given information, but the information was not correct. Let's say if I'm asking a question, what is your age? So generally it has been observed that those who are unmarried girl and boys, they are trying to underestimate their age. They have given response, but there is a bias in their response. There are separate techniques to how to check that response bias. There are various techniques. That is a separate lecture. We have a digit preference. There are Mayer index and Whipple-Meyer index through which we can capture age heaping and digit preference. All those things, there are separate things.
This is a question from Rohit Kumar. He wants to study investment decision making of investor of Delhi NCR, and please guide how I can calculate sample size.
I wanted to study the investment decision making of investor. Okay, so investment decision. So first you have to calculate that investment decision. So what is your final outcome? Investment decision means what? So are you able to calculate investment decision in particular sector if you are interested? Yeah. So that thing you have to first calculate that how much is the prevalence of that investment decision. For investment decision, you might create an index or some parameter through which you can calculate prevalence of investment decision, and that prevalence you can use in this formula.
Equity investment he has mentioned, ma'am.
Which one?
Equity investment.
Equity investment. So
Yeah.
first you have to find out how much is the what proportion of population are spending on equity investment. What proportion of population are investing in that? So that would be your P. And then you can calculate Q. Then you can choose your margin of error. You can choose alpha and you can calculate sample size.
Thank you, ma'am. I think that's done with the question answer session. All the questions are answered by you very well, ma'am. And people are appreciating and they are commenting like the session was very informative and very much useful. So everybody, all the participants, they like the session a lot. So Liji ma'am, you're there?
Yeah. Thank you, ma'am.
Shall we proceed, ma'am?
Yes, definitely. And ma'am, we are really, it was a wonderful session. Along with you all, even I was calculating. And, after a long time, I started calculating. Thank you so much, ma'am. It was really wonderful session and you clarified a lot of doubts which most of us have. And definitely we would like to have one more session of yours in the coming academic year from IQSC because we really want to know more on this area. Many of my colleagues also will be talking about it. Is that fine with you, ma'am, in the next academic year?
Yes, definitely.
That time it will be a physical, we'll be calling you in the college and let's have it.
Yes.
It will be really good because we really learned so many things. Thank you so much.
Thank you, ma'am, and thank you, everyone. It's actually a good session where people have started asking questions. Then I realize, okay, they are actually following because, there are a lot of concepts are involved that sometimes I lost that how I should link each and everything because there some basic statistics is required so that we can start this one because a lot of concepts are required. So it was good session. I would say, yeah, I enjoyed a lot. Thank you all. Yeah, thank you.
Please proceed.
Yeah, thank you.
One second.
Let me get this opportunity to propose a formal vote of thanks, ma'am.
Okay.
So first of all, I would like to thank ma'am, Dr. Priyanka Dikshit, because ma'am, you explained things very well and you made the participants to calculate And so it gave some kind of practical relevance to them. It was not only conceptual, but a lot of technical things were there, and you actually made them to solve, and you actually explained the formulas, what are the types of errors and what is the formula for those errors. So it was a wonderful session, ma'am, very informative. And second, I would like to thank the benevolent management and the principal of the college for always motivating and motivating us to keep organizing such kind of sessions. And vice principal of the college and ITOC coordinator, Dr. Liji Santosh, for organizing such informative sessions for all of us and helping us to grow. And vice principal, Professor Sandesh Shetty, for his constant support and motivation. Next, I would like to thank all my teacher colleagues and technical team who is always there to support us. And I would like to thank all the participants for being there with us throughout the session and for actively participating and getting involved in the session. Thank you. Thank you, ma'am.
Thank you, Priyanka ma'am. Smita ma'am, you can send the feedback link.
Yeah,
Done.
thank you. Thank you.
Done, already done.